Hey folks, thanks for joining this talk. Today we're going to be talking about how to accelerate your workflow from local prototype to the cloud. First, we'll talk about a common problem that I think a lot of us have faced in the past and why working in the cloud can be challenging. Next, I'll talk a bit about the Azure Developer CLI as a solution to this problem. Then we'll finish up with a bit of a demo about how it works and how it can help you in your end-to-end workflow. But before diving into the bulk of this talk, I just wanted to give a bit of context for who I am. In case we haven't met either in person or on the internet, I'm Savannah Ostrowski. I currently work at Microsoft on Azure Cloud Native Developer Tools and Experience. I'm also the product lead for the Azure Developer CLI, which I'll cover quite a bit during this talk. Before that, I worked on the Python team at Microsoft, and I was the product manager for the Pylance language server, which if you use Visual Studio Code, powers the editing experience there. I also worked on some other things like Python in Visual Studio, Python in WSL, Python in VSCode.dev, and also did some general Python ecosystem research. Before that, I worked as a software engineer at some startups and consultancies, doing both Python things and not Python things. So, to get started, I want to ask you to recall a time where you started building an app. You probably went through some form of speccing or ideation or feature requirement gathering phase, right? If you can't think of something, maybe let's consider a to-do application where you can keep track of daily tasks. You probably want to add some features like the ability to add tasks, add due dates, tick things off when you've completed them, or organize them by category or into lists. And for most folks with these sorts of requirements or features, it's fairly simple to figure out that at a basic level, you need three major components. You need a front end, a back end, and a database to store all of the tasks and all the right metadata. So from there, you need to make some decisions, and this is the first set of big decisions for your application. You might have some existing knowledge about libraries and frameworks, have a tech stack that you've used before, or you might need to do some research to identify the best options for your application. After careful consideration, you decide to take those components that you outlined in the ideation phase and choose some libraries and frameworks to move forward with. You pick React for your front end, Python with Fast API for your back end, and MongoDB for your database. And from there, you start building, or maybe you designed and started building in tandem. I'm not here to mandate any particular development process. So then you get a local prototype working, and then comes the fun part, getting the app hosted or up in the cloud so that you can share it out with the world or your audience. From there, you probably decide that you need to do some research, but this can quickly spiral into a lot of questions. As you research and stumble upon official docs, blogs, tutorials, more questions pop up, like which cloud services should I use with my code? How should I set up my local development environment? How do I provision the right infrastructure for my application? How do I know that what I'm doing incorporates security best practices? And some of these questions might not have answers that are super straightforward. And even after doing some research, you might end up with "it depends on X, Y, or Z" being the answer to any one of these questions, which makes things even more complex. But why is it so complicated? If you've ever considered investigating cloud services, you might have been confronted with a solution that looked something like this, if you even got to this point. And right off the bat, you can see that our basic web application components with our front end, back end, and database don't map one-to-one with cloud resources, which adds even more complexity. Not only that, but there are also new problems added to the mix, like getting roles and permissions set up, setting up our local development environment to be compatible with the cloud, configuring our CI/CD pipeline for our deployments, and more. So obviously, that's a lot to think about and manage, and what started out as a pretty simple web application actually turned out to be a bit more complicated when we add the cloud to the equation. All in all, answering all of those cloud-specific questions, provisioning infrastructure, and deploying code on Azure, it's a lot to think about and manage, especially if you aren't well-versed in cloud architecture and best practices. If you're a new developer, you're already inundated with learning how to write Python. You might not have the bandwidth to take on learning yet another thing. If I think back to when I was teaching myself how to code, I was usually focused on one concept or one piece of engineering at a time. If you're working on business logic or you're even a professional engineer, you might not have the time to learn the ins and outs about the cloud. You might want to write application code, and cloud things are sort of peripheral to the primary thing you're trying to accomplish. They're really a hurdle on the path from A to B, where A is some problem and B is some solution for your customers. Sometimes you might have a dedicated DevOps engineer or someone in charge of thinking through all the engineering system bits of the product, but sometimes that's not the case. If you're at a startup or smaller business, you might not have that dedicated person, which means that the problem of going from local development environment to the cloud or provisioning infrastructure and deploying code is ultimately something that hinders your productivity and velocity. Thankfully, this is where tooling can really help us in the end-to-end journey from GitHub to local development environment to the cloud. So I want to take a minute to introduce something my team has been working on for the last year or so, which is the Azure Developer CLI, or AZD. AZD is an open source tool that provides higher level application developer friendly commands that map to key stages in your developer workflow so that you can focus on writing application code instead of focusing on atomic operations or resources on Azure. So we have commands like AZD provision and AZD deploy instead of commands that interact with specific resources and require you to pass in a bunch of flags and parameters. Simple and easy to remember is the name of the game here. And so you might be wondering, where's the magic here? Like, how do we get away with being so high level? And so our approach is rather declarative in that the CLI uses extensible, customizable application templates that include everything you need to get an application up and running on Azure. I like to think about these templates as cloud blueprints or recipes that include sample application code, as well as reusable infrastructure as code assets written in either Bicep or Terraform. These templates cover end-to-end scenarios that go far past Hello World. They also include things like editor configurations, skeleton pipeline definitions, dev container configurations, and more. And with the CLI, the idea is that we're not just supporting you in that provisioning infrastructure and deploying phase in your development lifecycle, but we also want to support you day to day in editor when you're writing code. These templates are also programming language idiomatic so that the conventions used are conventions that you're most familiar and comfortable with when you're writing Python. With these templates, the idea is that you can build on them and make them your own. So you can find a template that maps to your local app stack, remove the sample application code, swap in your own code, customize a CI/CD pipeline definition, and leverage all of the infrastructure as code assets that define our application on Azure without having to get too deep in the weeds. And so I want to take just a second to talk a bit more about infrastructure as code in case there are folks that aren't super familiar with this space. Each AZD-compatible template includes IAC files or infrastructure as code files written in Bicep or Terraform in an infra directory. This directory and the files inside it are integral to how the Azure Developer CLI knows what to provision for you and how to deploy your code on Azure. If you're unfamiliar, infrastructure as code is a way that you can manage and provision your cloud infrastructure and services via code. The files in this directory specify the services you want to create, their configurations, and how they interact. Using infrastructure as code, we can ensure that the environment is generated in the same way each time everything is deployed to the cloud. Infrastructure as code also means that instead of you or your team needing to manage or maintain environment settings individually, you can work off of the same well-documented code that represents the desired environment state, avoiding deployment issues by keeping everything consistent. With the template ecosystem, you don't necessarily have to learn about infrastructure as code on day one of learning about the cloud, but I did want to highlight these because they are really important. They're a really important part of any Azure Developer CLI template. The best part is that you can always start with the files included in the template and then dig into the cloud specifics or tweak configurations slowly when or if your application requirements change. So I've done a lot of talking up until this point, and I think that this will resonate a lot better if I just do a quick demo. So let's hop over to Codespaces. All right, so I have an Azure Developer CLI compatible template here. This template is a containerized React web app with Python API and MongoDB on Azure. And in here, we can take a look at some key pieces of information. We've got prereqs, we've got a quick start to how to get started, which I'll show you in just a second. And then we have an application architecture diagram. And this kind of goes over what resources we're going to use on Azure and how everything's stitched together, just so that folks can do a bit more research when and if they have the time. So let's open this up in a Codespace. I already have a Codespace running to save us a bit of time. But first off, I want to open the README for this project just so that everyone knows and I know that we're in the right project. So I'm looking at a containerized React web app with Python API and MongoDB on Azure. Same repo. Okay, so we are going to open our dev container JSON. And so if you're unfamiliar with what a dev container is, it's really a way of you're setting up your development environment in a container. And I love it, especially for Python development, because it is a really nice way of handling all of your runtime dependencies and making it really easy for people to work off the same project. And so in this case, we are able to specify things like our VS Code extensions, which are useful for this project. We also have things like exposed ports. We have the Azure Developer CLI installed. we're basing our image off of this Python 3.10 bullseye, which means we'll have Python installed. We also install Node for our front end. And this means that when I open my code space, everything is installed for me right from the get-go. It also means that if I were working locally in VS Code, I could use this to work inside of a container on my local development or on my local machine with using Docker. And so I just want to call this out because it means that I can hit the ground running with this template really quickly. So from there, I want to talk about what makes an Azure Developer CLI project Azure Developer CLI compatible. And so the first thing we're going to talk about is this azure.yaml file. This is included in every Azure Developer CLI compatible project or template. This specifies all of our services, all of our kind of application components, that front end and our back end service, and then points to Azure Developer CLI at the right source code. So in this case, I have an SRC directory with a web and API subdirectory. But as long as you could pass in a path, you can structure your project however you'd like. It also specifies the languages for our project. So we have JavaScript for our front end and Python for our back end, and we're hosting on container apps. But you don't need to necessarily think about that. We're just trying to get this hosted somewhere. The second requirement is this infra directory with a main.bicep. We're using bicep as our infrastructure as code language or provider, but you could also find templates that use Terraform as well if you prefer Terraform. And here, that's where we're going to see all the resources that were in our architecture diagram defined programmatically. And so we can check this into our source control and have this live alongside our application code, which I love. In here, we're going to see things like our resource group, which is kind of our bucket or container, but container is sort of an overloaded term for all of our resources for this application. Next, we have a container app environment. And this is basically the nice little environment container around our containers that set up our secure boundary and our network and all that stuff so our containers can easily talk to one another. And then in here, we have web and API container app instances. So we're going to have two containers running for our front end and back end. And we have Docker files in our API and web directories. So we are going to use that to build the images. And then we have Cosmos DB for our database for Mongo. And then Key Vault for storing our application secrets because we don't want to be inlining our tokens and passwords. Monitoring infrastructure. And then we have a bunch of outputs. So these are going to end up as environment variables for the Azure Developer CLI in a .azure directory when we go and do our provision. And so, yeah, that's pretty much the main requirement is that main.bicep file. So we've looked at two requirements, Azure YAML and infrastructure as code. Those are the two big things. But I want to take a second to also talk about some things that aren't requirements for Azure Developer CLI, but something that can be included in templates that make development just nice. Because we do want to support you beyond that but beyond just the provisioning and deployment, but also when you're editing code in your preferred editor. So here we're in code spaces. I've got a VS Code directory with launch JSON and a task JSON for setting up our debugger. We've got example skeletons of GitHub Actions and Azure DevOps pipelines where we install AZD and then run AZD commands to do provisioning and deployment, which I love because when we're actually, codifying our deployment process, we're not going to be triggering that from within our local development environment. We're going to be doing that on tag or on push to a specific branch on GitHub. All right, so those are kind of the main requirements and some kind of optional nice things to have in an AZD template. I'm going to run AZD to find our help so we can take a look at some of our commands and make this a little bit bigger. We have simple commands. So you're going to run things like AZD up, AZD down, AZD provision, AZD deploy with no flags, no parameters, just really, really simple. I have the Azure Developer CLI extension installed in VS Code because of my dev container configuration, which means that I get to have some additional kind of convenience ways of triggering AZD beyond just typing in the kind of embedded terminal in code spaces. So I'm actually going to right click. I'm going to open this up a little bit bigger. But I'm going to right click on our Azure YAML in just a second here because that's an entry point for AZD. Like I said, it's a way that we know this is an Azure Developer CLI compatible project. So if I right click on Azure YAML and I scroll through the context menu, I will see Azure Developer CLI or AZD in there. I'll also see all of these AZD commands that we would see if we typed azd-h or opened the command palette, I'm going to be selecting what I would argue is maybe the most magical command that the Azure Developer CLI has to offer, and that's azd up. So I say it's magical because it really combines 3 commands into one command. It combines azd package, azd provision, and azd deploy into a single gesture. So that will package our application. So in this case, we're going to build Docker images. Then it's going to provision infrastructure based on our infrastructure as code files, that main.bicep. And then it's going to deploy our code. It's going to take those container images and put them on a container for us so that we can run our front end and back end. All right. So I click that and I'm asked for an environment name. I've already authenticated on Azure using azd. I typed azd auth login earlier and I authenticated in the browser. All my subscriptions are living in azd has access to all of my subscriptions. And so I'm being asked for this environment. I want to mention for kind of a Python audience in particular, that azd environment isn't your virtual environment. It's an environment that is going to be used on Azure. And so if I put in the question mark, I'm going to get some help text here. It says it's a unique string that can be used to differentiate copies of your application on Azure. So you might have things like dev, test, and prod. That's totally reasonable. And azd does handle that. We're not going to cover that today, but that's kind of why environments are pretty powerful. I'm going to use PyGotham for my environment name here. And then we're going to hit enter. And then I'm going to be asked to select a subscription. So again, I've already authenticated. And then I'm going to be asked for a location. I'm just going to click East US 2 to keep things simple. And then azd is going to go orchestrate a bunch of work on my behalf. So we're going to build some Docker images here real quick. And I say orchestrate because azd isn't really doing anything magical. It's just making things easy for you. So it's going off and it's, making images. It's going to provision and deploy code. But you could very well work through all these steps manually. But we're just trying to streamline that onboarding and management of your application on Azure. And I think non-magical is nice as a developer. If things are too magical, I usually ask questions. Okay, so now we're on to provisioning infrastructure. We are going through that main.bicep and we are creating all those resources. So I opened this file that was created for us, which is a .azure file. This file is where azd is going to store all those bicep outputs that we saw at the bottom of our bicep file. So in here, we already have passed in PyGotham, which is our environment name, our location, and our subscription, and also some Booleans for whether or not our services exist yet. And then as our provisioning is running, we're going to see all of these kind of individual, those same bicep resources printed out in our terminal, along with a unique identifier that we could go and reference to in the Azure portal. I don't like going to the Azure portal. I like staying in my local dev environment. So we're just going to stay here, wait for azd to finish kind of building out all of our resources for us. And I want to kind of mention this because I think if you're unfamiliar with kind of using cloud native infrastructure, it's not just hosting your stuff and throwing it on a VM. We're using kind of the right cloud resources so that you have all of that monitoring infrastructure, you have, roles and permissions set up, you have all of the configurations, everything's wired up for you on day one, which means that you're kind of set up for success and you can make like small changes little later on when you have, things you need to work through with pretty minimal effort because we use the right resources from the get-go. And there's nothing wrong with necessarily using a VM, but this is kind of a cloud native way of actually getting your app hosted in the cloud. So this does take a bit longer than it would to just like throw a zip or a binary on a VM, but it's nice because we have that single gesture. We can go get a coffee and come back. Now we're on to deploying. So what we're doing here is we're going to be taking those container images that we created in the packaging step based on those Docker files that were in our SRC directory for our API and our web. And we're going to be pushing them up to a container registry on Azure and then using those images on our container instances in Azure Container Apps in that Azure Container App environment. And so right now we're updating our container app revision, but this does take just a couple seconds because again, we are generating the image, pushing it somewhere and using that image. So I'll just pause here and wait for this to finish up. Cool. So everything finished up. We have our 2 endpoints, just scrolling through the output. It's pretty simple, straightforward, pretty visible, and also has good links if you want to go to the portal. We also did this in about 7 minutes and 55 seconds. So remember, that wasn't just throwing something on a VM. It was creating Docker images, container images, going and provisioning the resources, putting our images on a registry on Azure, pulling them down onto our containers, all in about 8 minutes. All right, so we're gonna go and click these URLs. We're gonna be brought to 2 endpoints, one for our front end, one for our back end. On our back end, we have kind of a swagger.yaml, so we can explore all of our endpoints for our application, which is pretty cool. And then we have a fully fledged application running on Azure infrastructure. It's wired up to a database, a Cosmos DB database. And I can go ahead and I can add to-do items. I can go and add due dates. I can tick things off. All of that fully set up for us. And again, you don't have to necessarily care about that to-do part. You could, mainly care about that React, Python, MongoDB combination, rip out that source code, pop in your own source code, and hit the ground running just like we did with AZD app. Okay, so as part of our provisioning, we also set up monitoring infrastructure. That includes log analytics workspace. It also includes dashboards. And so we're going to use another gesture called AZD monitor to actually jump directly to our monitoring infrastructure, all those dashboards. And so I actually just opened the command palette with Command-Shift-P or Control-Shift-P, depending on your operating system. And then we can we can type AZD or Azure Developer and then navigate to monitor deployed application. And we have this in our command palette because we have the Azure Developer CLI installed. So I'm going to click that, and then I'm going to be asked if I want to view live metrics, logs, or overview dashboard. I'm going to click overview dashboard just to keep things simple. And I think this is it's pretty nice because if you've ever tried to navigate the Azure portal, you can often end up clicking through a lot of different screens before you get to the place you want to be. This brought you directly to a dashboard that's showing you usage, reliability, and responsiveness metrics for your application. So pretty awesome. All right, now I want to show arguably my favorite Azure Developer CLI feature, which is setting up our CI/CD pipeline. Again, when we're actually building an application and meaningfully using it, we're not going to want to be triggering our deployments from a local development context. We're going to be, pushing a lot of code and wanting to re-trigger deployments based off of, a new tag or push to main branch, something like that. We can do that with AZD. So AZD, in this template that we have a skeleton GitHub action and also an Azure DevOps pipeline, if that's your flavor of CI/CD provider. And in here, I have the skeleton that defines how I can do my provisioning and deployment in my pipeline. So I'm using the Azure Developer CLI official GitHub action, this setup AZD. That's going to install the AZD into the runner. And then we're going to authenticate on Azure using federated credentials, which is the default for GitHub actions. Federated credentials, OIDC, OpenID Connect. This is a security best practice, which we love. And then if we scroll down a little bit in this file, we're going to see that we're using the exact same AZD commands that we can use in the local development context. So we used AZD up earlier, which is packaging, provisioning, and deployment, or AZD package, AZD provision, and AZD deploy, which is fine. But we can also trigger these individually. And in this case, and we're also passing in no prompt, which means that it's non-interactive. And so instead of providing it with that, environment name, your location, and your subscription, we are actually setting that up we're going to set that up using a gesture called AZD pipeline config, and refer to that information from within the pipeline. So you don't have to do any kind of interactive stuff, which wouldn't work anyway. So with that said, let's go and right click on our Azure YAML again, navigate to Azure Developer CLI, and then click configure a DevOps pipeline config. So this is going to open the embedded terminal, and it's going to go off and it's going to set up all my repo secrets and variables for me. So I don't know if you've ever walked through this process manually before, but it is quite tedious and it can be a little bit confusing. So it's creating a service principal for us so that GitHub Actions and Azure can talk to one another securely. And then it's also going to ask if I want to commit and push all these changes. So I'm going to set up my CI/CD pipeline. So it tells me, and it will, if you didn't have a repo set up upstream, you could also set up a private repo with AZD as well during this flow. Cool. I'm in a dev container. I also have the GitHub Actions extension installed for VS Code, which means that I can monitor my pipeline from within my editor. And for me, this is amazing. I love staying in my editor. I don't want to be clicking around in the browser. Super straightforward. I can monitor everything I'm doing right from the context that I like to work in. All right, so we've seen an end-to-end workflow. So let's wrap that up and go over the AZD workflow one last time. So to start, the first question might be, what do I want to build? And this is sort of the ideation phase of the development process that I mentioned earlier. Via the AZD template list command or by visiting the AZD templates topic on GitHub, you can browse templates that support you in finding the right foundational recipe for your application in the cloud. Then you can either use AZD init or git clone to pull the template code down into your local dev context, or just open it in a code space like I showed off here. From there, we can modify the template, make it work for our application-specific requirements. Remember that these templates were designed to be flexible. You can also make your own code base AZD compatible and create your own template by using the AZD commit command as well, in case you can't find a recipe on GitHub. Now it's onto the cloud with AZD provision and AZD deploy. Using these commands, you're able to provision the right resources for your application, deploy code on Azure, based on those infrastructures code assets that are either written in Bicep or Terraform included in the template. Better yet, you can use AZD up to wrap up packaging, provisioning, and deployment in a single step, which is what I showed off earlier. Finally, let's talk about best practices. With AZD Monitor and AZD Pipeline Config, we can set up and view our monitoring and dashboards, as well as set up a CI/CD pipeline for our code base. And that pretty much wraps up this talk. I hope that I convinced you that the cloud doesn't have to be so hard when you have the right tools to support your workflow. I'll leave this slide up if anyone's interested in the materials from this talk, installing AZD or our docs, or checking out our GitHub repo. Everything is open source. And also, we host community stand-ups once a month following our monthly release on YouTube and on Twitch. And it's a great time to chat with me or the rest of the devs on the team about upcoming features or the release. We also have an open source template gallery, which is called Awesome AZD. And in here, I've included a short link to find the Python templates on Awesome AZD that are compatible with the Azure Developer CLI. So I want to thank you so much for watching this talk, and I'm really excited to see what you build.